Bismillahirrahmanirrahim. Hello, dear students. I hope you are all doing well. I welcome you all to the class of real analysis. In today's lecture, we will discuss some important properties that is related to supremum and infimum of a set. These properties are actually very important with respect to your exam point of view. So before going to discuss these properties, we will revise some basic definitions that we will use in our today lecture, which are the lower and upper bound of a set and the supremum and infimum. I hope you are already familiar with all of these definitions. So let us start. The first property says that show that the supremum and the infimum of a non-empty subset of an ordered field F is unique. Supremum and infimum of an ordered field subset of an ordered field F is always unique. Let A be a subset of an ordered field F, and suppose on the contrary that A has a two suprema. Supremum S1 and S2. There are the two supremum S1 and S2. Then by definition of supremum, both are the upper bounds of A, because you know supremum is the least upper bound. So supremum is one of the upper bound. So both are the upper bounds of set S. Supremum is one of the upper bound. So both are the upper bounds of set A. Consider case number 1, or suppose when S1 is the supremum of A, then in that case S2 will be an upper bound of A. So firstly we suppose S1 is the supremum of A, then in that case S2 will be the upper bound of A. That satisfies the expression as I have discussed here. Upper bound is always greater than equal to the least upper bound. Upper bound is always greater than equal to least upper bound, mean to say upper bound is always greater than equal to supremum. So when you will take S1 as a supremum and S2 is a upper bound, then S1 will always less than equal to S2, because S1 is here our supremum and S2 is here upper bound. So this is the least upper bound, this is the upper bound. Obviously upper bound will be greater than or equal to the least upper bound. Second case, say this is as inequality number 1. Now we suppose S2 is the supremum of A. If S2 is the supremum of A, then S1 will be an upper bound of set A. So similarly as above, S2 that is here at this time a least upper bound, S1 that is here a upper bound. So the least upper bound will be less than equal to upper bound. So this will become S2 less than or equal to S1. Combining 1 and 2, we have in one the inequality was S1 less than or equal to S2, while in inequality 2 is S2 less than or equal to S1. Both the inequality have their common sign, that is equality. So S1 equal to S2. This shows that the supremum of a non-empty subset of an ordered field is unique. These are not two supremum, these are same. So this is the first property. Similarly, you can show that the infimum of a set is also unique. Next we will move towards the property number 2, that can be stated as here. Let E be a non-empty, let E be a subset of a complete ordered field F. Obviously this E is a non-empty. E is a non-empty subset of a complete ordered field F. Now at this time F is a complete ordered. A field is called complete ordered field if it satisfies the supremum property, least upper bound property. We have to show that if let E is a subset of a complete ordered field F such that infimum of E exists in F, let us define a new set minus E that consists on all the negative elements of the set E. For example, suppose our E is 1, 2, 3 up to so on 10. Then according to here minus E will be minus 1, minus 2, minus 3 up to so on minus 10. This will be minus e. Then firstly we have to show that minus e is bounded above. This is our first task. And the second one, we have to show that infimum of e is equal to minus times supremum of minus e. We can justify both of these properties by this example. Clearly, we have to show that minus e is a bounded above. Bounded above means a set which has an upper bound, which has an upper bound. You can notice that there are many elements which are greater than the elements of set minus e. For example, one of the element which is greater than minus 1 is 0. 0 is greater than all other elements of minus e, and 0 is also belong to the real field R. And next we can notice that 0 is an upper bound of this set minus e according to the field R. So this set minus e is a bounded above subset of R. This is a bounded above. A subset is called bounded above if it has an upper bound. So 0 is an upper bound. This is a bounded above set. So according to this example, we find infimum of E. Our set E is this. What is the infimum of E? Infimum of E is here 1. That is a smaller number a number that is smaller than or equal to every other elements of set E. So infimum of E is equal to 1. On the left side, we have to calculate on the right side supremum of minus E. What is the supremum of minus E? Supremum of minus E. Supremum of minus E means an element which is greater than or equal to every other element of set minus E, which is equal to minus 1. So you can verify that infimum of E. Sorry, here this is infimum of E. Infimum of E is equal to minus time supremum of minus E. Infimum of E is 1 and supremum of minus E is also minus 1. This is equal to 1. 1 is equal to 1. That shows this property is right. Proof. Next we prove this property in general. Let us take alpha is equal to infimum of set E. We have to show this property. We will take alpha as an infimum of set E. Then according to definition of infimum, what is the definition of infimum? The definition of infimum says that this is an element which is less than or equal to every element of set. So if alpha is the infimum of set E, then alpha will be less than or equal to every element of set E. So if elements of set E are X type, so alpha will be less than or equal to X. Multiply on both sides with minus X to make the elements of set minus E. The inequality sign will reverse here. So minus X will less than or equal to minus alpha. This shows that minus X is less than or equal to minus alpha. Now you have to find which set has elements minus X. As X are the elements of set E and minus X are the elements of set minus E. Your set minus E is elements of this type. This contain all the elements of X type, where minus E consist on negative elements that can be formed from set E. By just taking negative sign with elements of set E, we can make elements of set minus E. So here all the elements of set minus E are less than or equal to minus alpha. Then minus alpha will be the upper bound of set minus E. So minus alpha is an upper bound of set minus E. So minus E is bounded above. This is our first task that we have to prove. In the second task, hence there exists second one. This is our first task, that is complete. Next we have to show that this property, infimum of E is equal to supremum of minus E. As minus E is bounded above and E is a subset of complete ordered field F. E is a subset of complete ordered field F. Now the completeness property of F state that if E is a subset of F, then it has an upper bound. If upper bound of set E exists, then its supremum also exists in F. Because E is a subset of complete ordered field F, completeness property gives the guarantee that E must has supremum in F. Hence there exists supremum of minus E. Let beta is equal to supremum of minus E. Our target is to show that supremum of minus E, infimum of E is equal to minus times supremum of minus E. Throughout the properties of supremum and infimum, one strategy that I will use, we say that for two real number, if A is less than or equal to B and B is less than or equal to A, this implies A is equal to B. So let beta is the supremum of minus E. This is supremum of minus E. Suppose this is the beta. This implies beta will less than or equal to minus alpha. How beta is less than or equal to minus alpha? Because minus alpha is an upper bound of set minus E. Where we have defined this? This is every element that is minus x, which is the element of set minus E, less than or equal to minus alpha. This shows that minus alpha is an upper bound of set minus E. Minus alpha is an upper bound of set minus E. Now beta is supremum of minus E. So beta is the supremum of minus E. I have discussed that supremum, that is the least upper bound, is always less than or equal to upper bound. So beta will less than or equal to minus alpha. Multiply on both sides with minus 1, we have alpha is less than or equal to minus beta. Next we show that the alpha is greater than or equal to minus beta also hold. Next we show that alpha is greater than or equal to minus beta. Conversely, since suppose that elements of set minus E are of T type, T belong to minus E, that is elements of set minus E is T. Beta is actually supremum of minus E. By definition, now I will use the definition of supremum of minus E. What is the definition of the supremum? Supremum says that this is an element which is greater than or equal to every element of set minus E. So if the elements of set minus E are T type, so T will be less than or equal to beta. T is an element, beta is a supremum will be greater than or equal to every element of this. We have, by multiplying on both sides, we have minus beta is less than or equal to minus T. As T is an element of minus E, so minus T will be the element of set E. T belong to minus E. This shows that minus T will be an element of minus E, plus E. T is an element of minus E. Minus T will be an element of set E. Now, a minus T, which is an arbitrary element of set E, which is greater than or equal to minus beta, then beta is called the lower bound of set E. Thus, this follows that minus beta is the lower bound of set minus E. Since alpha is equal to infimum of E, that we have assumed in the start, since alpha is equal to infimum of E, so this shows that what is infimum? Infimum is the greatest lower bound, and minus beta is lower bound. So what will be the relation between lower bound and greatest lower bound? Clearly greatest lower bound is greater than or equal to lower bound. So the alpha, which is infimum of E, is now greater than or equal to minus beta. By combining 1 and 2, we have alpha is equal to minus beta. Alpha was infimum of E and beta is a supremum of minus E. Hence, infimum of E is equal to minus times supremum of minus E. So these are the two properties that we have discussed in our lecture. Inshallah, in the next lecture, we will discuss next two properties which are also related to supremum and infimum of the set S. I hope today lecture is helpful for you, and now you have a clear understanding about today lecture. I again advise you before following this class, that is especially related to supremum and infimum, you have clear concept about the supremum and infimum. So inshallah, in the next lecture we will discuss the next two properties. Until then, take care. Goodbye. Allah Hafiz.